Jai Jirendra, Namaste. My name is Sayyam Jan. Welcome to my channel. Today we are going to solve the 34th question of the problem solving series, which is based on binary search. So this is the fourth question of the binary search. The difficulty level for this question is easy to medium, and this question has been asked in VMware, Flipkart, Amazon, Microsoft, and multiple big MNCs. So we need to find the square root of a number. Okay, so using binary search. So normally if we need to find a square root, like square root of 36 is we know 6. Square root of 105 is 10 point something, right? Square root of 100 is 10. So if we don't have the perfect square root, so we'll be getting the floor of that number. That means 10 square is 100 and 11 square is 121. It falls between this 10 and 11's square. So we will take the floor part, the 10 part. Okay, that is given in the question. Now, how do we solve this using binary search? Before solving it using binary search, how do we solve this question in general? If we need to find, okay, so we have the input is n and we need to find its under root. What do we do? What is under root, right? We know 1 into 1 is 1, 2 into 2 is 4. So 1 into 1 is 1, 2 into 2 is 4. So the under root of 4 is 2, right? 2 is square, that is 2. So if we want to find for 36, so we can keep on checking, okay, 1 into 1 is 1, 2 into 2 is 2, 3 into 3 is 9, 9 is less than 36, 4 into 4 is 16, less than 36, 5 into 5 is 25, 25 is less than 36, 6 into 6 is 36, okay, it is equal to 36, we return 6, right? So how many times we have run the loop? By max, we can run it 36, but we can divide it, okay, like any numbers double. If 5 is a number, its square root is 25, right? But its double is 10. So it must be between, like the square root of any number would be between, if we need to find the square root of n, so the square root's value will obviously be less than n by 2, right? Mathematically proven, right? Everyone knows. So if we use it normally by brute force approach, what would be our time complexity? Order of n by 2. The worst case, that is order of n. So we have to optimize it. How do we optimize it? We will be using binary search. So how do we solve this question using binary search? So we know we have solved previously 3 questions in binary search. We have low, we have high, and we find the mid part. We eliminate the left half or right half according to the conditions, and we keep on eliminating the half, and in order of log n we get our answer and we return. So how do we solve it using binary search? I'll directly code it and you will understand while you see my code. Okay, what do? We start with low, and low is equal to 0, and we have our high as n. Okay, so we have our condition that while low should be less than high. Now we have our int mid is equal to low plus high by 2, right? That is 36 by 2, or this one is 18, right? So what do we do now? We have our mid value. Okay, so for example, if the mid value was 6, then mid into mid would be 36. So 6 would be our answer, right? So if I take a int value and I do a mid into mid, assuming mid is 6, we do a mid into mid. Now if this value is equal to n, doesn't it mean we have our answer? We can just directly return mid, right? Because that is the answer. Because mid into mid is value, right? Else, if value is less than n, what does this mean? That means, say if value was 5 into 5 is 25. 25 is less than 36. So we need to increase our numbers, right? We need to go ahead. We need to see, okay, for the next number, it won't be smaller than 5. So what do? we increase low's value. Okay, we will eliminate the left half. So low would become mid plus 1 because mid is not going to be the answer. Mid square is less than the value this n. Okay, else what we will do, high is equal to mid minus 1. We have eliminated the right half. That means say if value is, for this example, right, 18 square is 324 and 324 is greater than n, that is 36. That means okay, 18 it can't be 18, we need to search from 0 to 18 then for this in this case, in the first iteration of this. So high becomes mid minus 1. So once in all these things we will be eliminating left half, right half every time, and then we will get our, finally we will get our answer. Okay, so our answer would be, in this case if we get our answer, if it is a perfect square we will get our answer like this. If it is not a perfect square, a time will come when high will become lesser than low, and since we need the floor of the number, so we will be returning the smaller part of mid and low and high, and that is high, so we will return high. So in this way we will be able to solve the question in order of log n. Also, I would like to tell that what if the question was finding the nth root of a number? What change we would have done? In that case, here we are multiplying with into it because we know that we want to find the square root. But in the question, it also could be given that okay, don't find the square root, find the fifth root. So in that case, we would have multiplied value. We have multiplied value 5 times, mid into mid into mid into mid. We would have write a function, and then we would have that 5 times multiplied value, and then we would have implemented it in the same way. So finding the square root of a number using binary search, finding the nth root of a number using binary search, everything would be same, just this value will be taken accordingly. Here we have just multiplied it twice. Okay, so I hope the explanation is clear. I would suggest to try it yourself. The link to the question has been given in the description. Please try it yourself and then come to my code walkthrough section.
Here is the code walkthrough of the 34th question and the 4th question of the binary search, finding the square root of a number in the Gigs for Gigs, and the companies it has been asked are this, and this is the code, the same what I have explained. So I'll just directly submit this. So you see it has worked fine, and I've already said that I showed the implementation. If the question was asked to find the nth root, then also you would have implemented it in this way by giving the number of times the value has to be multiplied depending on the number of root it is asked, or the 4th root or 5th root. Okay, so I hope the explanation is clear. The code walkthrough is easy, and see you all soon in the next video where I'll be explaining the 35th question of the problem solving series. Jai Jinendra.